Let's take a bit of a look at cubics. The perfect cube, there it is. A cubed plus 3a squared b plus 3ab squared plus b cubed. Notice it's a cubic. Every individual term has 3 pieces of algebra there. The first one is an a times an a times an a, the next one an a times an a times a b, and so on. Why? Well, because think about what you're doing. It's a plus b times a plus b times a plus b. Essentially, you're taking one pronumeral from each of those parentheses and multiplying them together. Hence why you end up with 3 pronumerals in each term. A minus b cubed, essentially the same pattern, but it alternates, plus, minus, and so on. And to generalise that one, okay, you'll have every individual term cubed. You'll have 3 times every possibility that when you take one of the pronumerals out twice and another one out once. So we've got a squared b and a squared c and ab squared and so on and so on and so on. But there's now another possibility where you just take 3 different ones out of each. And for example, a, b, c. You'd also have, if there were more pronumerals there, say it was plus d, you'd have a, b, d and b, c, d. But there'd always be 6 of those. There's your expansion. Difference of 2 cubes. A minus b is the first factor, and then the second one, that's where you've got to be careful because it's a squared plus ab plus b squared. It's so tempting to write a squared plus 2ab plus b squared because we're so used to writing it with our binomial perfect square, but it's only 1ab. And plus, we have a plus one as well. Very similar, but you'll notice the factors, it starts the same as the question. So it's a minus b cubed, we start with a minus b. If it's a cubed plus b cubed, we start with a plus b. And in the second one, if it was minus in the first one, then they're all positive. If it's plus, then the signs alternate. So plus, minus, plus. 2a minus 5 cubed then, if I expand that out, again I'm not saying you would write this line down, but we're saying, hey, it's the first term cubed minus 3 times. I'll take that first term twice, so 2a squared, and I'll take the second term once, times 5, then I'll flip it round, so I've got 3 times 2a times 5 squared, and then I've got 5 cubed as well. There's our answer. If I wanted to factorise then x cubed plus 8, it is the sum of 2 cubes. Again, I'm not saying you'd write that down, that's more what you're thinking. So the first factor will be the x plus 2, we match the question, and then in the second one, well now it's going to alternate because it's plus in the first one, so I get x squared minus 2x plus 4. Difference of 2 cubes, so again, that's what you're thinking, y cubed minus 3a all cubed. So the first factor is y minus 3a. That now means all the terms in the second one are positive. So we get y squared plus 3ay plus 9a squared. In fact, we can generalise that one too. A to the power of n minus b to the power of n will always be the first factor a minus b. That brings me back to what I said about the difference of 2 squares. You remember I said, oh, which factor would you put first? That is why I always put a minus b first. You match the pattern. It was difference of 2 squares, I went a minus b then a plus b. So always a to the power of n minus b to the power of n, first factor a minus b, and then the second factor, because it's minus in the first one, they will all be positive. But basically you're starting at a to the power of now n minus 1. All the powers go down by 1 of the a, but now all the powers of b go up by 1. The 2 powers always add up to be n minus 1. We do not have an a to the power of n plus b to the power of n though, because you only do a to the n plus b to the n for odd powers, and that's why we don't have an a squared plus a b squared. Now if I have an odd one, x to the 5 minus y to the 5, I'll start off with x minus y. Now the powers of x's are going down by 1, the powers of y are going up by 1. It's an odd power. Hang on. A to the power of 7 plus 1. This is why it works for an odd power, because what you can basically do is rewrite that. Because that plus 1 I could rewrite as minus, and then minus 1 to the power of, in this case, 7. That's not going to work with an even power, because minus 1 to the power of an even will be a positive number. So you won't create that plus. The only possible way you could do it would be via the use of imaginary numbers. Then you could create a negative. But that's not something we're looking at yet. And that is also then why in the second factor the signs alternate, because essentially you're saying minus 1 to the power. So the first one would be minus 1 to the power of 0, which is a positive number. Then the second factor would be minus 1 to the power of 1, which is negative 1. Then minus 1 to the power of 2, which is positive 1, and so on and so on. All right, you'll notice I say Old Cambridge. In the handouts at the back of it there should be a copy of that exercise.